Okay, guys, let's talk about a little bit what we're going to be doing today. Today, we're going to be looking at medians and altitudes of triangles and mid-segment of triangles. How can you find the balancing point, the interior of any triangle, what are the properties of the triangle, the vertices are the midpoints of the three sides of a triangle. We're going to be applying these properties and proving them. Okay, first up, median of a triangle. Median is a segment whose endpoints are a vertex of the triangle in the midpoint of the opposite side. Every triangle has three medians, and the medians are concurrent. Write all that down. Don't worry so much about the diagram just yet. Okay? Key part that you got to remember is this. Median ends up in that angle, right? It goes from the midpoint to the opposite angle. Midpoint to opposite angle. There we go. All right, let's move on here. From our medians, we get this. The point of concurrency of the medians of a triangle is called the centroid of the triangle. From our centroid, we get the centroid theorem. The centroid theorem says the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. That makes sense. Remember this, the centroid is always inside the triangle. The centroid is also called the center of gravity because it is the point where a triangular region will balance. 2/3 the distance from the vertex to the midpoint of the opposite side. Put this in context for you. Y is a midpoint of B to C. Say well with y'all get it right. All right, so y'all look up here. Y, we talked about this yesterday. Y is the median between B and C, right? Midpoint, mid-segment, right? Y is the midpoint there, okay? So I go from my midpoint, and my median is from Y to A, that opposite angle, okay? All right? I just have this going on 3 different ways, so don't freak out about that. Let's talk about Y to A. The distance from A to P is 2/3 the total distance from A to Y. So if A to Y was 3, A to P would be 2, and P to Y would be 1. 2/3 the total distance. Okay? Give you another example here. Don't write this down, just look up here. Tells me R to L, the whole thing is 21. What is the distance from L to S? If the entire distance from R to L is 21, that means the distance from L to S is 2/3 the total distance. Take 21, which is my total distance, multiply it by 2/3. You can use calculators, others you can remember how to multiply fractions. 7 times 2 is 14. That's how I get that 14. Break this down even further. If R to L is 21, L to S is 14, how far is R to S? Try it again. R to L is 21. L to S is 14. How far is R to S? 7, right? 14 and 7 is 21. Okay? Look at this example. This one's harder. The tougher one. S to Q is 4. I want to find the total distance into Q. Okay? Well, the whole thing into Q is broken up like this. In S, it's 2/3 total distance from N to Q. Okay? my total distance from N to Q equals 2/3 the distance into Q plus 4. Again, I can take the distance from N to S, which is just 2/3 the total distance into Q, add it to S to Q, which is the remaining part of that N to Q, and add 4 to both sides. I'm sorry. And I would get my total distance. It's kind of strange how this sets up algebraically. Notice that N to Q is my common variable here. I subtract 2/3 NQ on both sides. This is where it gets weird. If I'm talking in whole form, and my denominator is 3, how much would a whole be? What would make a third whole? How many thirds? Okay. So ignore 2/3 for now. Okay. If I put 1 in fraction form, okay, 1's in fraction form, and I have 3 as my denominator, how many would my numerator be? 3. So a full 3/3 of N to Q. That would be the total distance from N to Q. It's 3/3. I told you it was kind of strange. Okay. At this point, you can divide both sides by 1/3, or you can multiply by the reciprocal. That's how I get NQ. It's 12. The toughest one I can give you. No, they're not all that tough at all. Okay, but I wanted to show it to you, to show you how you can work it out. Okay, it is possible. It's kind of complicated, but it's possible. Okay, make some other relationships. All right, except for actually. All right, let's talk about this real quickly. Here's what I want you to write down. Altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. Please write our helpful hint as well, which is that the height of a triangle is the length of it. How it goes. Okay, move on. Good. Just write this, okay? We're not going to talk too much about orbital center. This point of concurrency of the altitudes is called the orbital center of the triangle. That's all that you need to write down. Pretty sure they took orbital center out of our standards, but just in case that you still get asked about it, we'll have an idea of what it is from your notes. So fun, so fun. All right. Moving on to the next one, which is called the mid-segment. Mid-segment of a triangle is a segment that joins the midpoints of two sides of the triangle. Okay, mid-segment joins the midpoints of two sides. Let me give you a visual here. Y is the mid-segment of QR. X is the mid-segment of, I'm sorry, Y is the midpoint of QR. X is the midpoint of QP. XY is the mid-segment. I'll say that again. Y is the midpoint of QR. X is the midpoint of QP. XY is the mid-segment. Okay? Every triangle has three mid-segments, and they form what's called the mid-segment triangle. You'll see triangle inside triangle, right? So how many triangles do I have right here in this diagram? 5. Pretty good. The big one and 1, 2, 3, 4. Kind of cool. So geometry nerd. Okay. Real quickly, I want to distinguish something. This can be confusing, especially today. The median of the triangle, you'll recall, goes from a midpoint to the opposite angle. Median goes from midpoint to opposite angle. Midpoint to opposite angle. Okay? So the dashes or the dots, they represent what would be the median. Right? The median intersects, and what do we call that word? Starts with a C. Yeah, the point of concurrency is called the centroid. Okay, centroid. Just put that one down. Centroid. Now, though, this is no longer going from midpoint to opposite angle. Now we're going from midpoint to opposite midpoint. Midpoint to midpoint. Those are called mid-segments. Here's a hint. XY is parallel with PR. XZ is parallel with QP. I'm sorry, did I say XZ? YZ is parallel with QP. XZ is parallel with QR, which sets up my triangle mid-segment theorem. I'm going to write this down. Triangle mid-segment theorem says mid-segment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. All right. I skipped over something real quick. Let me go back to it. You don't have to write it down. You know, you run out of room. Let's talk about how we start off all this stuff, okay? This is talking about, okay, how would I work a problem to find the mid-segment and all that good stuff? So first off, let me go back to this example. Imagine I started off this problem and I said, hey, the coordinates of P, Q, and R are such and such, right? Here's the coordinates for P, here's the coordinates for Q, here's the coordinates for R. Plot those points. Then you would use your midpoint formula to come up with the midpoints of X, Y, and Z. That's what they do here. Okay? Plot the points, use the midpoint formula. Then we would get to the slopes. Okay? So notice my slope for XY is going to be the same as the slope for PR. That's why they are parallel. They have the same slope. Same thing YZ and QP. Same thing XZ and QR. Finally, I would use my distance formula. Okay? The distance formula is going to show me that the distance from XY is half the distance from P to R. The distance from X to Z is half the distance Q to R. The distance from Y to Z is half the distance Q to P. Okay? Triangle mid-segment, the theorem itself is this explosion of information, right? Midpoint formulas, slope formulas, and then my distance formula. Okay? Those are the three big ones that we'll do in here. So if we need help with slope formula, we'll work on it. I didn't put too much on that today, but I wanted to show y'all an example of what a problem might look like a maybe constructive response type problem, right? You'll see that. You're going to be plotting the points, and then you're going to be finding the midpoints, finding the slope, finding the distance. Okay, I got one more. These are pretty easy. Y'all check out how easy this can be. Though. If you memorize, and not only memorize, but you can apply. Okay, you can apply this theorem. You're in great shape. A to E is 17. BD and AE are parallel. What would be my distance from B to D? Well, if these two are parallel, and I've got three different midpoints being connected, that means BD is the mid-segment of AE, which means it's half of 17. Now, half of 17 is 8.5. Okay? It's not so much the math. It's easy to say what's 17 divided by 2, right? It's thinking about what it means for it to be a midsegment. Try another one. Okay, new question. Let's do these together. I'm going to have you guys do these on your own. Let's do them together. Don't worry about writing them down. Just pay attention. It's all on right now. Get off your phones and pay attention, please. Use the diagram to find each measure. Look at it. Okay, is E the midpoint of BA? Is F the midpoint of B and C? There should be 2 there. Is D the midpoint of AC? Okay, so I've got 3 midpoints. They're connected. Those are called midsegments. It's crucial that you get this. If BC is 20, what's the distance from E to D? 10, half, right? If F to D is 7, what's the distance from A to B? 14. 7 times 2. 14, right? Look at this last one. What's the measure of BFE? Well, notice this. These 2 triangles are similar. Remember that similar triangles have congruent corresponding angles. So B to F would be 44 degrees. You're going to get some problems on today's classwork where you got to remember your transversal rules. Okay? And you will have questions for me, I'm sure. Does anybody need any of these other slides?